All right, so we said that reactions happen at different rates. So let's take a look at some factors that affect how fast or how slow a reaction goes. And so the first one is the nature of the reactants. And so this one, you kind of have to have a good knowledge about chemistry and the reactivity of compounds. And so some compounds are simply more or less reactive than others. The second thing that affects reaction rate is the physical state. So in order for compounds to react, they must physically touch one another, right? You can't build a car if your parts are in different cities, and you can't build a molecule if your molecules are not touching one another, right? And so that's why generally solids aren't used, because they're very slow. They have low surface area, low contact area, and so they're generally really slow. Unless they're powderized, then they'll go somewhat faster, but still relatively slow. So if you grind it down into a powder, you increase the amount of surface area, and so the chemicals are touching each other more, and so they can react more. So this is why most chemistry is done in solutions, right? When we do chemistry, generally we dissolve something in one liquid and then dissolve it, or dissolve our second component in another liquid, and then have those two react in solution. It's to increase the number of collisions that we have between the molecules and thus increase the rate. Number 3 is the temperature. In general, when you increase temperature, your rate generally goes up. So at higher temperatures, things go faster, generally. Of course, there's some exceptions. And kind of the rule of thumb here, it doesn't always work, but it's pretty good. It's every 10 degrees Celsius of an increase that you have, your reaction rate is doubled. And so this is exponential, so it's actually very powerful. So let's take a look at an example of what happens when we increase the temperature by 30 degrees Celsius. So you went from maybe 0 to 30 degrees Celsius, right? So go ahead, pause the video and think about that for a little bit. All right, so hopefully you thought about that. So let's think about going from 0 to 10 degrees Celsius. So that would be 10 times faster, or twice as fast, right? Twice as fast. And then we go another 10 degrees Celsius up to 20. That's twice as fast of that other rate. And then we go another 10 degrees up. That's another doubling of the reaction rate. And so if you take all of these and multiply them, you've actually increased the rate of your reaction times 8, right? It is 8 times faster. The other way is, of course, to do this stuff through exponential. So 2, since it doubles, and then 2 to the n would be every 10 degrees, right? So 2 to the 3 is 8. The fourth factor is the concentration of the reactants. And in general, when you increase concentration, you increase the rate, right? A more concentrated reaction will go faster than a slower reaction, or than a less concentrated reaction. And then finally, we have what's known as the presence of a catalyst. So we'll learn about catalysts a bit more later on, but let's just go ahead and introduce this idea. And so a catalyst is something that speeds up the rate of a reaction, but isn't used up during this reaction. So it helps make the reaction go faster, but it's not it's not used up during the reaction. It's kind of like a worker, right? A worker goes in, they do some stuff, but then they still get to leave. They don't, your mechanic doesn't become part of the car. He just helps make it. So an example of that is going to be a catalytic converter. So this is found in your car, and your catalytic converter is made out of platinum, or has a tiny amount of platinum in it. And so what this does is it takes carbon monoxide, which is very toxic and very bad for humans, combines it with some oxygen, and then forms CO2, which also not great, but much better than carbon monoxide. So this reaction by itself would happen normally, but it would happen very, very slow. And so what we do is we add a catalyst. We add some platinum to this to make it go faster, right? And so this is the catalyst. And so it speeds up the reaction, but isn't in one of the sides of the chemical reactions because it isn't used up during the chemical reaction, right? Even if you drive your car for 20 years, right, there's still the same amount of platinum in your catalytic converter.